Hi grade 9s, we're going to go over how to use our PHET, P-H-E-T simulation here. So I want to just show you where all the parts are. So first of all, this is how it will come up on your screen, and on this side you have all of the parts that you can use in your different circuits. So it goes down all the way to where you can add in a dog, a pencil, a hand, different types of wire, bills, coins, erasers, fuses. There's way more in here than what we are going to use necessarily in our class. There's also whether you have electrons or conventional current. Now, if you have an electrician in the family, electricians use conventional current, which assumes that the positives move. They did this before they figured out that it's actually the negatives that move. So always make sure yours is on the electrons, and you'll see that they'll be moving around with little circles with the negative inside just to help you out. You have your voltmeter and your ammeter over here. We are not going to need the advanced at the moment. So to make your basic circuit, you're going to take a battery, you're going to take a wire, and you're going to attach one side over here, lift it up, grab the other one. Now you'll notice with this light bulb, it actually is done correctly in that the bottom of your light bulb and the side of your light bulb are the two different parts that you have to touch. You can't touch both wires to the bottom. It won't work. So if you've got a regular light bulb here, you have one contact point here and then one on the side as well. So the contact points have to be separate. So this is what the simulation is drawing or showing you here. So then your other wire, you're going to grab to that point and you're going to bring it back down to your battery, and oh, you've already made something, and it's very exciting. So couple things to note. You can see that the electrons are moving. You can see the direction that they're moving. They come out the negative and go into the positive and go through the battery. You've got a certain amount of light coming out that shows you the brightness. Now, if I double tap, onto our battery, it tells you what the voltage is. So you can pump up the voltage, and as you do that, you'll notice that the brightness of your light gets significantly brighter, and the electrons move significantly faster. As you slow this back down, this is the energy that it's giving to the electron. So it's the motion or the amount that it needs to move. So you're going to have this, if you push it faster, they're going to go faster. If it's slower, they're going to go slower. Or not at all if you turn it off. Then you can also say, put this back down at, I think it was at 9 volts, because that's your normal. It's actually not your normal battery. But then you can tap your light bulb. Now here you'll notice it's resistance, and it's now being measured in ohms. So if you increase the resistance, you get less light. If you decrease your resistance to 0, the battery lights on fire. Now, I know every single one of you is going to make the battery light on fire because it's very exciting. We don't actually want to do that in real life. But as you turn down the resistance, you get a brighter and brighter light bulb. As you push up the resistance, you're making it harder and harder for the electrons to flow through. As you make it harder for them to flow through, the brightness is going to decrease. So that's why you're going to have it go down. Now, what else can I show you on here? We don't need this anymore. Oh, that just threw that out. Interesting. So here, when you want to snip them apart, the little scissors comes up and you can just snip it apart. Now, if you wanted to, because I know you're going to, we can go to our dog and we can attach our dog to our circuit, and we can see if we can turn up the voltage and make anything happen. And then I just jumped while I was watching that, because then the dog jumps because he's getting shocked, and it breaks the circuit, which is very interesting because that is a new feature of this, is that it would break and move away from the circuit. So obviously I think that's animal cruelty, and I don't think you should do that. But if you wanted to put your own hand in there, I don't think this makes it jump. So this is already at 150 volts, so it's saying that it's not going to hurt, which I don't actually think that's true. So we're not good conductors. You can put in a pencil, and you'll see that there's a current that will flow through that. A pencil is a better conductor than you are. It's always good to know. So if you click on the element, you can just trash can it down here. If you want to get rid of the whole thing, behind my head on this side over here, I don't know if you can see it, over here, there's an orange button with like a little round, oh, I can't even press it because I'm on top of it. Okay, there it goes. It'll get rid of everything and you can start again. Now, another important thing that you're going to need to know is how to find the ammeter, like the voltage and the resistance. So if I use a light bulb again, I'm going to put this here. You're going to have a voltmeter. Now voltmeters are always attached in parallel, and I know that we haven't really done what parallel means yet, but basically what it means is in the loop running around is a series. Parallel means on the outside adding another path. So if we want to know the current that's going through the light bulb, we can take our ammeter and put it right beside and bring our wire up, and it'll tell us the current. If I want to know the voltage, I have to put my little probes on either side of our light bulb, so where the wire is connecting on either side. But this kind of sits outside of the circuit, so your voltmeter sits outside of the circuit, whereas your ammeter is right inside of the circuit. So if you need to find out how much voltage or how many amps you're putting in, this would be a good way for you to do it. Now I realize I just pulled that down while I was talking, but I just thought that might be a better, so we can add more things in there. Now if you wanted to, you can make very complicated circuits and you can add them in many different ways. You can have a whole bunch of different light bulbs. You can play around with this, add resistors, add another battery. If you're adding batteries that are going in two different directions, it won't work. That's important. So if you want to add a battery in, you have to turn it around so that they're going the same direction, or we'll push the current in the same direction for them to work. Okay, so there's lots of different things you can do with this. You obviously have a list of things that you're going to be doing for this lab. I'll go over that as well, but just overall, this is the main things you need to know. Now, there's one other thing that I wanted to show you. So if I set up my battery, my wire, a light bulb, and I get another wire here. I'm going to put a resistor on here so you can see the difference, and another wire. And then if I actually want to be able to draw this with the proper symbols, which you're going to need to be able to do, you've got the battery mode here, and then on this side shows you what the symbols will look like. So this is the correct circuit symbols that you can use.